Alright, so you guys see that we are now working on question 19A3, question 1. And this is the one where we have the box that is of uniform density weighing 100 newtons. So that means that when we say it is weighing 100 newtons, we know that this is going to be our mg. Moves in a straight line with constant speed, and we know that constant speed, a must equal 0 meters per second squared. Acceleration is 0. So the coefficient of sliding friction is 0.4. This is going to be our mu, and exerts a force, and this rope exerts a force F in the direction of the motion as shown above. So now we need to draw and identify all the forces in the box. So of course we've got our force F that the string is pulling. This would also be called tension. We see that it is on a surface, so we do have the upward normal force of a surface that is always perpendicular to that surface. And then we know that gravity is pulling down on this box. We've got our mg. And then we see up here, they say that we've got this sliding friction, which is going to be this force going to the left, because we know that our velocity is to the right. And friction opposes motion. So now we need to calculate the force F exerted by the rope that keeps the box moving with a, again, constant speed, so we know that our acceleration is 0. So let's go ahead and set this up. So we've got our sum of the forces equals 0. And so what forces are acting on this box to keep this force being 0, to keep this acceleration 0, to keep it moving with this constant velocity? And so we see that because we're going to the right, let's just go ahead and call the right positive. So we're going to say F minus this little f, which is our friction. And so then we can now add this little f, which is friction, to both sides. And so we see that this force is equal to the friction. And that makes sense because our acceleration is 0, and if our acceleration is 0, our forces are balanced on both sides. If they're balanced, then we know that this force of the rope must equal our force of the friction. And another thing that we know about friction is that friction equals mu times normal. So now we can say this force equals mu times normal. But what is normal? We did not get normal, so now we're going to have to find that normal force. And we also see that these are the forces in the x direction that we just were dealing with. And now we're going to deal with the forces in the y direction, because we see that our normal is pointing up, and so we're going to be dealing with the y direction now. So let's say, so some of the forces in the y direction again equals 0, because we're not accelerating upward, we're not accelerating downward. And let's just call up positive, so we're going to say normal minus this mg. So now we can add this mg to both sides. And we get normal equals mg. And now we can plug in this mg for that normal force right there. So we get F equals mu times mg. Now let's plug in. Mu, they said, is going to be this 0.4, so 0.4. Our m is, or our mg, actually, remember, our mg is going to be this 100 newtons. So we just say times 100, and we get a force of 40 newtons. And that is